Solar panel energy harvest is key to understanding off-grid PV luminaire performance. In today's video, we will be using a solar meter to measure solar radiation flux density, commonly referred to as watt per meter squared or kilowatt hours. Using a solar meter, we will be able to accurately track and monitor solar intake, allowing us to further explore factors that can affect PV luminaire operation. In our first case, we will identify the differences between solar panel placement under shade compared to no shade. With our first trial, under a shaded environment, you will notice a reading fluctuating from 80 to 155 watts per meter squared. After placing our Sunlight 8-watt luminaire under flush sunlight, you will notice an initial reading at 555 watts per meter squared, steadily rising. In our second case, we will observe the changes in solar intake after tilt angle is introduced. Our first example in a horizontal position records a reading between 620 to 630 watt per meter squared. Following with a tilted angle, our readings record a significant boost to 850 watt per meter squared. In our final case, we explore how dust and debris can interfere with PV energy harvest. Using a clean panel, our readings display 653 watt per meter squared. Applying a clouded cover on top of the solar meter, we can mimic the effects of heavy dust and debris. Our meter now displays 556 watt per meter squared, a considerable drop. Please keep in mind that many factors play a role in optimal PV luminaire performance. Panel location, position, and placement will all affect energy harvest. In order to ensure a successful luminaire operation, remember to side with a quality system while being mindful of the geographic setting. For more information on off-grid solar lighting solutions, please visit www.soltechlighting.com.